Ladies and gentlemen of geometry, welcome to 9-6. This is talking about surface area and volume of spheres. Spheres kind of play by a little bit different rules than other three-dimensional objects. That's why we talk about them separately. Just because they look a little bit different and follow a little bit different rules. So spheres basically three-dimensional circles. So what you want to look at is kind of all these things that and kind of connect the dots here. So if we look at a chord, is a segment that connects any 2 points on a sphere. Okay, so that's going to be your chord. Your diameter is going to be a chord that contains the center. All right. Now, a radius is a segment. Let's start circling these from the center to the point on the sphere. All right. Now, intersects the sphere at one point. That's going to be the tangent. All right. And then the poles are considered the endpoints of the diameter of a great circle. So all that we have left is a plane that intersects the circle at center. That's going to be your great circle. Basically, the great circle is the biggest circle that can be made by trying to cut the circle, the sphere in half. So surface area of a sphere. So what you've got is to start thinking about in terms of circles. So the area of a circle would be pi r squared. And then if you think about it, if you look at it from the top, from the bottom, from the left and the right, you've seen every single part of the sphere that there is to be seen. So if you look at it from 4 views, so that's pi r squared, that's 4 circles, and that ends up being your surface area of a sphere, just 4 pi r squared. So like 4 circles from the top, bottom, left, and right. The volume of a sphere is a little bit different. And this is basically from, there's a long drawn-out process as to what this is. So it is 4/3 pi r cubed. Now cubed, think about volume, you're thinking about three-dimensional space, so that's how you remember that this is going to be cubed. So 4/3 pi r cubed. So I'll find the surface area of a sphere, so I want 4 pi r squared. Okay, so it's 4 pi 6 squared. So 4 pi 6 squared, so that's going to be 144 pi centimeters squared. Okay, now this is exact, considered exact, but then if I wanted sorry, blanking here. The other version, I would take 144 times pi. So that would be the exact, so the rounded answer, sorry about that, the rounded answer would be 452.389 centimeters squared. That is a 5. So that's going to be my answer with the exact and the rounded. So surface area of the sphere, so this time the diameter is 22, that means the radius is 11, so that's going to be 4 pi r squared, so that's going to be 4 pi 11 squared, so that's going to be 4 pi 121, so that's going to be 484 pi feet squared, and again, that's going to be exact. Then if I want the rounded, that's going to be about 1,520.53. So that's going to be my answer in feet squared. So the circumference of the great circle is 5 plus meters. Figure out the surface area, or 5 pi meters. So circumference, remember, is twice the radius times pi. And that's going to equal 5 pi. So if I divide by the pi first, cancel, cancel. So 2r equals 5. So if I divide that, I get my radius to be 2.5, or 2.5. So now I want to go back and figure out the surface area. So I want 4 pi r squared. So that's 4 times pi times 2.5 squared. So 2.5 squared times 4. So that's going to be 25 pi meters squared. Okay, and that's exact. So if I convert that to a rounded answer, that's going to be 78.54 meters squared. So there's my answer. So find the surface area of a sphere if the area of the great circle is approximately 130 square inches. So it's approximately 130 square inches. So that'd be pi r squared is the area of a circle. That's going to be 130. So that's what I'm going to work with. So what I want to do is divide by pi. And so r squared equals 41.3803. So if I take the square root of that, so I get my radius to be 6.43275. So now when I go to figure out the surface area, that's 4 pi r squared. So if I turn around and square that, I get 4 times pi times 41.3803. And if you're saying to yourself, well, why did he take the square root and then turn around and square it? I didn't really have to, but I like just knowing what the radius is and working from there. I could have gone straight from here down to here and not had to re-square it. That would have been fine. Just, it's not a bad practice just to always get in the habit of looking for your radius. So if I multiply these two together, I get 165.521 pi. So multiply that times pi. You know, this we consider to be your exact. And when I multiply it, I get 520 inches squared. I should label that up here too. So this is your rounded. So 520. Wow, it actually worked out that way. So volume of a sphere with the great circle circumference. So again, 2 pi r is going to be equal to 18 pi. So kind of nice, the pi just goes away. So 2r equals 18. So my radius will equal 9. So volume, though, that is where 4/3 pi r cubed. So 4/3 pi 9 cubed. So 9 raised to the third power. So when I do that, I end up with 972 pi centimeters cubed. Now this time it's cubed because I'm looking for volume. So now if I take that answer times pi, I get approximately 3,053.63 centimeters cubed. That's what I'm looking for. So that's kind of what I'm looking for. So now when I look, surface area of a hemisphere, volume of a hemisphere. Well, a hemisphere is just half of a full sphere. I mean, that's all a hemisphere is. So it's just going to be half. So all I'm going to do is take 4 pi r squared, 4 pi r squared. I'm going to divide the whole thing by 2. I get 2 pi r squared. Volume of a hemisphere, 4/3 pi r cubed, is for a full sphere. So if I divide that by 2, I end up with 2/3 pi r cubed. And that's going to be my answer. Just divide everything by 2. So there's my surface area. There's my volume of a hemisphere. So surface area of a hemisphere, pretty simple. 2 pi r squared. So 2 times pi times 2.8 squared. 2.8 squared times 2, 15.68 pi centimeters squared. So multiply that times that. And again, exact, rounded. That's my difference. So find volume. So half that guy. So it's going to be 2/3 pi r cubed again. So I'm going to take 2/3 times pi times 6 cubed. So 6 raised to the third. So that's going to give me 144 pi once I multiply all that out. So that's going to be meters squared. Now when I multiply it, escape, I get 452.389. So pay attention on the assignments. Pay attention on quizzes and tests. If it says exact, this is what I want. If it says rounded, that's what I want. So make sure that you got those two separated. So the stone spheres of Costa Rica were made by forming, I don't know how to pronounce the word, boulders into spheres. One of the stone spheres has a volume of approximately that. What is the diameter of that stone sphere? So you got to start in one place and kind of work backwards. So you got 4/3 pi r cubed equals 113,097.34. So let's start with this. If I divide by pi, let's start with that. That gives me 36,000. So now, solving this, if I multiply by a reciprocal, that gives me that. So now I want to take the third root. And in a calculator, what I do to figure that out is I'm going to take 27,000, I'm going to raise it to the 1/3 power. So take that and raise it, and then in parentheses, put 1 divided by 3 into your calculator. So when I do that, I get 30. So that is my radius, but remember the question asked for. The question wants the diameter. So my diameter is going to be 30 times 2, which is going to be 60. There's my answer. All right, thank you for playing. Come talk to me with questions, and we'll see you soon.